All right, you should have watched the Who Would You Be video. It features Mary-Kate and Ashley Olsen. Just a little fun fact for you. When I was younger, I used to be in Mary-Kate and Ashley Olsen's fan club. It was a real thing. You could they would send you like posters and videos that they were in and stuff like that. I had to pay like a monthly fee. But when I was a kid, I was part of Mary-Kate and Ashley Olsen's fan club, so that's exciting. Anyway, this video that we're doing now is going to really focus on some of the key phrases that were said in that fun music video. But instead of looking for a person or trying to be a detective searching during a mystery, we are going to be detectives deciding whether or not a story problem is multiplication or division. So you need these colors out. You need blue, purple, and lime green. And you need to put the date with lesson 3.12 and get your journal set up like this. Go ahead and push pause on the video until you get it done. Now that you have it done, it says, if we think it over, remember they say, think it over, and do some detective work, we can find out whether a story problem is asking us to multiply or divide. So there's some things that they say in this video that I really want to focus on. One of the phrases they say is think it through. So to think something through, it means you're not just guessing. You're looking for clues and using your past knowledge to solve that. So think it through. They also say, choose your identity. Did you catch that phrase? Instead of saying your, we're going to say the. Choose the identity. To have an identity means it's very specific and it belongs somewhere. So choose the identity. And another thing I like is during watching this video, they're doing a lot of searching and investigating, and they go and try something and then they say, like they put the mustache up to different people and they say, nope, you're not Mr. Kramer. So they're looking for someone. So we are going to be doing our own investigating and trying out the problem to see if it makes sense. So think it through, choose the identity, investigate. Okay? When we look at a story problem. We are going to come up with what are some of the clue phrases. So when you're a detective, you've got to look for clues, right? You have to talk to different people, you have to search the surroundings, you have to really use your reasoning skills and to deduct or to find out what is happening. Okay? So investigate. I think reasoning is a good word here as well. So I'm going to add it right here. To use reasoning means think about your answer that you get and make sure it makes sense. Okay? So all of those things are things we're going to work on. So there are some clues we can look for in a story problem, just like they were looking for clues in that video. There are some clue phrases that if you see in a story problem might help you decide whether it's multiplication or division. There are some clue phrases. So we'll give it away. You ready? Let's go ahead and come up with, we're going to do purple on this half of the box. And we're going to do green on this half of the box. So we're going to come up with some clue phrases for this. You ready? Let's go ahead and do a couple lines down. Notice I still left some space at the bottom. So, some clue phrases for multiplication. Some clue phrases for multiplication. Meaning, if you see these words in the story problem, you can start to believe that it is multiplication. Now, they're not always 100%. There is not enough evidence in some of these clue phrases, so you'll have to maybe do the work and see if your answer is reasonable or if it makes sense. So we are going to first come up with some clue phrases that we might see in a story problem if you're talking about multiplication. Here is one that I think comes up a lot. If you see the word of and it shows up multiple times. So we'll put usually will show up several times. If you hear the word of multiple times, it probably means that you're going to be multiplying. Here's an example. Brian had 13 baseball cards. Of those baseball cards, 1/4 were pitchers. How many of the cards were pitchers? So 1/4 of, right? Of means multiply. If you see the word each, like they each cost this amount, or the actual word times, that might come up. You also might hear times as many. You could hear multiply, like it might actually tell you to multiply. And you could hear product. Remember, the product is the answer to a multiplication problem. Yeah, it's going to be some of these words that are going to be in there for multiplication. Something I want to make very clear, though, is I kind of grouped these ones together, so hopefully you did as well. This each, times, and times as many. Remember, these are not dead giveaways. It is not always. Not always doesn't mean multiply. Sometimes it can mean division. Sometimes these ones can mean division. So you have to be really careful that these ones right here are sometimes. These ones are sometimes. They're not always. They're sometimes meaning multiply. Because guess what? Sometimes they can mean division as well. And we'll find a couple story problems today that focus on that. But you just need to make sure that this is sometimes also this one. And sometimes that one. So we'll make sure to add them over there as well. Let's go ahead and move on to division. Some division phrases that we would hear, you're going to hear these ones. You're going to hear words like share. They're going to share, or they're going to cut something up, or they're going to break it into pieces. If you hear evenly, they're going to share something evenly, equally, or groups. Equally, you might hear groups, like they're going to put something into groups of. You might hear the word split. Let's see, did we get cut? Or did we do break? We did. We did share, cut, break. Oh, you might actually even hear the word divide, right? They're going to divide something into groups. Split comes up quite a bit. Equal or equally. Those are going to be, okay, it might use equal or equally. It might actually say the word quotient. Sometimes it even says, like, if you're going on a hike and you're going a certain distance and you're going to take a break, it might even say something like you're going to take stops. Sometimes the word each or times as many, right? Those ones can also be this. So I'm going to put them over here as well. Each, times as many. Remember, those ones were the ones that were also over here. So we're going to just do the little caret that says, we'll do actually a little bracket this time. This says sometimes. These three words right here are sometimes multiply and sometimes divide. So it gets a little tricky, but that's why we're detectives. We're going to figure it out together. And then you're going to be figuring it out on your own. So when we evaluate a story problem, when we're looking for whether this is multiply or divide, we're going to start searching for these clue phrases. These clue phrases. You know, sometimes you hear the word pieces also for, did we do pieces over here? We didn't. Sometimes you hear the word pieces. So there's a lot of words that we're going to be looking for and searching the text for. What you need to do is at the bottom of your paper, we're going to write sample problems, or let's maybe come up with a phrase from the video. Think it over. Who would you be? Let's see. Choose your identity. Oh, I love the beginning of the video. It says, what if a magic genie said to you, you could be anyone you want. Now tell me who. So we're going to write, now tell me who. At the bottom, all capitals. Now tell me who. So we are going to be you're going to be doing that on the back side. You need to outline this in blue. Then you need to go find page 117. So finish outlining this in blue and then go find page 117. Go ahead and pause the video until you get both of those things done. Rip out page 117 and turn your journal page. So push pause on the video until you get page 117 ripped out. All right, at the top, you need to make sure that you have your name and number. And I'm going to slide my journal to the side, but I'm going to use my journal, those phrases that we came up with. So maybe I need to turn back the page so that I'm looking at these clue phrases and have page 117 out and ready. Okay? Make sure that you leave the two colors out that we're going to be searching for. Remember, if we find words that mean multiply, we're going to use purple. If we find words that mean divide, we're going to use green. So it says, decide whether you need to multiply or divide, then solve. So here we go. Number 1. A turtle crawls 3 yards in an hour. How far will it crawl in 2 hours? So a turtle crawls 3 yards in an hour. How far will it crawl in 2 hours? So do we see any of these clue words? I don't see of. I don't see times or each. I don't say split or divide. I don't see any of these clue words. So what we're going to do is just think it through, right? Choose the identity. So it goes 3 yards in an hour. How far will it crawl in 2 hours? So this is going to be multiplication. And if you knew that, maybe you could think through, how would you explain that? How would you explain it without any of these clue words? The first one is multiply. You just have to think, well, there's 3 yards in an hour in 1 hour. So how far will it crawl in 2 hours? So the equation will be 3 times 2 equals x. That's the equation. So how far will it crawl in 2 hours? It will crawl 6 yards. Make sure you get the right measurements. So in an hour was kind of our clues, because then we saw that they wanted you to figure it out for 2 hours. So that was multiply. Now it says, how far will the turtle crawl in 1/4 of an hour? So it's still going to be multiplication. How far will it go in 1/4 hour? I would say in 1/4 of an hour. So that's the same thing here. So how far will it crawl in 1/4 of an hour? So remember, it goes 3 yards in an hour. Okay, so it's going to be 3 yards. But now, how far will it go if it only goes 1/4 of an hour? 3 times 1/4 equals x. Remember, when you multiply, you just throw a 1 underneath, so it looks like this. Keep everything the same. That's only with division that we change. Multiply is you just throw a 1 underneath and you multiply straight across. But you also look for relationships. So I see the 1 and 1, so it's times. I see the 1 and 1 will cross each other off, and I'll just be left with 3/4. And it will be 3/4 of a yard. So think about if that makes sense. Oh, we didn't circle 6 yards. Yeah, if it doesn't even go an hour, it can't go 1 yard. If it doesn't even go an hour. So it has to be a piece of a yard, and that was. This one, he goes 3 yards in every hour, and then he went 2 hours. So you do 3 times 2, and that's 6. So both of those are logical. All right, let's try number 2. See if we can find some clue words here. Emily has 2 tons of sand. She will move it by wheelbarrow to the garden. Her wheelbarrow holds 1/10 ton. How many trips will she make? So she has 2 tons of sand. She's going to move it in groups of 1/10. How many trips will she make? Well, she's going to be making a lot of trips because it only holds a fraction of a ton, a small fraction, and she has 2 tons. So she's going to be moving it a lot. Okay? So if I did multiplication here, let's just say that I tried multiplication here. 2 times 1/10. This would be like in the video going to put a mustache up on somebody's face to see if it looks like that person. We're trying multiplication to see if it looks like it could be a reasonable answer. So what do you do with multiplication? You throw 1 underneath the whole number, you extend the bar, and you multiply straight across. You can look for relationships if you want. That would work too. I could divide both of those by 2 to get that. And then I have 1 times 1 is 1, and 1 times 5 is 5. 1/5. She's going to make a 1/5 of a trip? Does that make sense? Is that reasonable? No. How can you make a 1/5 of a trip carrying stuff in a wheelbarrow? This is not logical. This was like holding up the mustache to someone's face and being like, nope, you're not it. This is not reasonable. So even if, I'm trying to show you, even if you can't find keywords, you can pick one of the operations and see if it's reasonable. But there actually is one key word here. And we learned it a lot with the division. So we know it's division because multiplication didn't work. But why don't you scan that story problem to see if you can find division clues. Emily has 2 tons of sand. She will move it by wheelbarrow to the garden. Her wheelbarrow holds this amount. How many trips will she make? Look right here. She's splitting up her time, even though it doesn't say the word split. She's splitting up the amount by time. It also says stops. And instead of saying stops, couldn't it say trips? How many stops? How many trips? Let's add that to our journal. Yeah, it does say that. Or she's going to split up or break up, right? So the word here that actually is helpful is trips. Also the word has. I don't know if you remember that about division, but when we say what you have is what you put first. Remember that? So the equation will be 2. She's got 2 tons, and she's splitting all of them up by 1/10 sizes. So how many 1/10 trips is she going to make? That is the equation. So when we divide by a fraction, here's a tip. Keep, change, flip. So keep, change. How do you flip 1/10? It becomes 10. So she's going to make 20 trips. I'm just going to put trips right here. I'm trying to stick to this part right here. she is going to make 20 trips. I love that we tried multiplication to make sure we're thinking it through. I love that. Let's look at number 3. Tana has 3 pounds of nuts. She is using them to fill small bags with a 1/4 pound each. How many bags can she fill? So I see a keyword here. I'm just going to use my pencil. I see each. But look how difficult this is. The word each is on both sides. So I'm going to use my investigation skills. Tana has, tells me how much she has. She's going to fill small bags. So isn't she going to share the amount she has into bags or split the amount that she has into bags? So we're just going to write these keywords maybe off to the side. What she's doing here is she's sharing or she's splitting. That's what she's doing with her amount. So we know that this is division. It is division. So think about which number is going to go first. Well, it tells you. What she has goes first. So the equation will be 3 divided by 1/4 equals x. To divide by a fraction, here's a tip. Keep, change, flip. I'm going to separate it. That's what that is. We're just doing the problem right here. So how many bags can she fill? They're only going to have a 1/4 pound in each one, but she can fill 12 bags. That makes sense because she's only putting a little bit of a pound in each bag, and she has 3 pounds. So she's going to be able to fill 12 bags. Those bags aren't going to be full of a pound. They're going to be full of what? A 1/4 pound. Okay, number 4. Roberto has a recipe that calls for 4 cups of flour. He wants to use only 1/2 of the recipe today. How much flour will he need? He wants to use 1/2 of the recipe. 1/2 of the recipe. So he's going to be using 1/2 of everything that's in the recipe. Of 4 cups of flour. He wants to use only 1/2 of the recipe. So if I'm going to be doing 1/2 of the 4, what does that look like I'm going to be doing? Of 1/2 of the 4. All right, there it is. It's multiply. 1/2 of 4. This is a multiplication problem. 1/2 of 4. Okay, cool. So I write it like this. 1/2 of means what? Multiply. 1/2 times 4 equals x. When I do multiplication, I just throw a 1 underneath the whole number. So everything stays the same, but 4 becomes with a 1 underneath it. So this is me solving the problem. So if I go, you can simplify right now. I'm actually just going to multiply straight across because of what I see. It's easy for me to just to go 1 times 4 is 4, 2 times 1 is 2, and 4 over 2 is 2 whole. So how much flour will he need? He will need 2 cups. And that is logical because he's doing 1/2 of 4. What's 1/2 of 4, everybody? 2. So pretty easy. Number 5. A jug holds 1 gallon of sports drink. Each plastic cup holds 1/12 gallon. How many plastic cups can be filled? So I see the word of, but does it come up here multiple times? No, it's just part of telling the story. So a jug holds a gallon of sports drink. Each plastic cup holds 1/12 of a gallon. How many plastic cups can be filled? So I have a gallon and I'm going to be filling something. So I'm going to be splitting the gallon into these. This is another problem that is going to be split or shared. So that's pretty interesting. So I'm going to be doing division here because of the can be filled, and it holds a gallon. So 1 gallon. So I'm going to take what I have, which is 1 gallon, and I'm going to be using, what was it again? Division. So I'm going to be using division again. So I take what I have, which is 1 gallon, and I divide it by the amount that's going in each one for my equation. To divide by a fraction, here's a tip. Keep, change, flip. How do you flip 1/12? Just becomes 12. How many plastic cups can be filled? 12 cups can be filled. So I want to try something off to the side right here. Let's see, what if you didn't know that this word filled also means that you're going to be splitting that gallon or sharing it? What if you thought this was multiplication? Let's just pretend that we think it's multiplication. So we're going to go, is it multiplication? Let's pretend this for a minute. I would take 1 times 1/12, right? Well, to do this, so 1 times 1/12. To do this, I would put a 1 underneath it, and then I would multiply straight across. So 1 times 1 is 1. 1 times 12 is 12. So this is what the answer would be. Is this reasonable? If I had a gallon of a sports drink, like this means like Gatorade or Powerade, and I'm going to pour it into cups, and each of the cups hold a 1/12. Could I pour 1/12 of a cup? No, that is not reasonable. So even if you did the wrong operation, even if you tried multiplication, when you got to the end of it, you should have been like a detective and thought through, that doesn't make sense. All of these need to make sense. Okay? Number 6, I'm going to pause. What I'm going to do is I'm going to put the operation bubble right here, and I'm going to pause I'm going to freeze the camera. So I'm going to put what operation this is, and I want to see if you can figure out what operation it is at the same time. Ready, go. It rained on 2/5 of all the days last month. On 1/6 of these rainy days, there were thunderstorms. On what fraction of the days last month were there thunderstorms? Oh, that's nice. It tells me it's going to be a fraction. But that's not the clue. The clues are some of the words in there. It rained on 2/5 of all the days last month. On 1/6 of these rainy days, there were thunderstorms. On what fraction of the days last month were there thunderstorms? Ready? 3, 2, 1. You should have written the operation. It's multiplication. Here are the words. On 2/5 of all the days, and then on 1/6 of those rainy days. So you're doing 1/6 of that fraction. That's why it's going to be a fraction, and they tell you that it's going to be a fraction. So on 1/6 of 2/5, that's what's happening. 1/6 of 2/5. And what do we know that of means? It means multiplication. So I'm just going to solve this right now. I multiply straight across, or I can first look for relationships. I see a relationship, and I don't want to do 2/30. So I'm just going to divide these ones by 2 right now. So it now looks like 1 times 1 and 3 times 5. On what fraction of the days last month were there thunderstorms? There were thunderstorms. On, let's go ahead and put it right here. 1/15 of the days. I'm just going to make sure that gets circled. There were thunderstorms on 1/15 of the days. So we found that there's going to be some times when it's obvious that it's multiplication or division, and then sometimes when it's not so obvious. But even when it's not so obvious, you can tell me who. You can figure it out by solving it one way and thinking through it, going, that can't be right. That can't be right. So I love these types of problems. What we're going to do now is we are going to, well, let's see. Let's see what's on the back side of this. Now, we are going to cut this out and glue it on the back side of our journal. So I want you to, right now, go into the back side of what we did, and you're going to cut this out. I want all of it. 1, 2, 3, 4, 5, 6. I don't know if I'm going to get to keep this crazy, like the not reasonable stuff we did, but we're going to try. I'm going to cut around it, cut up and around. See what I'm doing here? I'm cutting out any of the work I did. You should do the same. Let's keep the title as well, just not your name. We'll keep the orange title. Let's see if we can get this. Remember to cut off anything you don't need on the sides by the numbers. Let's see if we can get this to fit on our journal without covering any of the holes. Oh, mine can. Even with the crazy stuff I kept. Look, I'll show you. See how I'm zoomed out right here? So at the top, I can put this. As long as it doesn't cover up any of the holes, then we're good to go. So get that glued in to your journal. And then I'll catch you in the next video.